Hello, in this first lesson of Unit 3, Graphing, we're going to take a look at working with patterns. And in this series of videos, we're going to recognize patterns and relations. We're going to learn how to make a table of values to represent the relationship. And then we're going to learn how to write an equation that represents the relationship. We're going to be working through the pages starting on page 324 in your workbook. The first example on page 324 gives us a visual guide illustrating the relationship between the number of computers sold at a store and the number of computer games sold at the electronics store. So what they're saying here is for every computer sold, so one computer, they're going to sell 6 games. But then when they sell 2 computers, they're going to sell approximately 10 games. And when they sell 3 computers, they're going to sell 14 games. So what we can do is start to notice patterns. What is the pattern for computers? So we take a look and the visual will show us. We start with 1, then we go up to 2, then we go up to 3. We would expect that the next diagram would show 4 computers. So this is a +1 pattern. We're going up by 1 for our computers. What is the pattern for games? This doesn't follow the same pattern. We start with 6, then we go up to 10, then we go up to 14. What is the pattern between 6 to 10 to 14? In other words, what would you expect to be the next number for games? We can see that we are going up by 4. 6 up to 10, and then 10 up to 14 is a +4 pattern. So the pattern for computers is a +1 pattern, whereas the pattern for games is a +4 pattern. So from this information, we can make a solution or a statement that shows what we know. We know for every computer sold, 4 more games are sold. So that if we sold 4 computers, we would then have 18 games, using that +1 pattern for computer and +4 pattern for games. So then the question we could look at next would be, well, how many games will be sold when 12 computers are sold? What we could do is we could continue to draw the visual that we saw on the previous slide, but that wouldn't be very efficient, especially if we were looking at hundreds of computers. So we're going to look at a few methods that will work for us. And the ones that we're really going to focus on are making a table and then an equation. You can see on the top of page 325, they did just that for method 1. They drew 12 computers, those larger boxes, and then they kept drawing games until they got to the number that they needed. That's a bit time consuming. A better way, our second method, is to make a table. And the table is a list format that can help us to continue the pattern. So notice that over on the left-hand side, we're using that +1 pattern, going down the line all the way to 12 computers. And on the right-hand side, we're using a +4 pattern all the way down, matching so that when we hit 12 computers, we see that we have 50 games. Again, this is a great method. This is a table of values. This is the basis for us forming equations. We're going to create table of values that don't necessarily have to go the full way to the answer we want. Because again, if I asked you how many games are sold with 250 computers, you would not want to make a big, huge table. That would take too long. But it is the basis for how we're going to figure out the answers. So remember, what we learned is for every computer sold, 4 more games are sold. So if the question comes, how many games will be sold when 2,512 computers are sold, we need a better method to be able to find our answer than drawing or creating a table that goes all the way from one computer down to 2,512. We're going to take a moment to see how we can set this up, and then we will solve this question. Let's look back at this table of values and kind of analyze what's happening here in the table. What we need to know is that any table of values that we make or see has two sides. On the left-hand side, these are the values that are called your x values. So later when we graph, they're the ones that are going to go on the x or horizontal axis. On the right-hand side are our y values. These are the ones that are determined based on the x values, and in a graph, they're the ones that are going to go on the vertical axis. And we'll get to that when we're ready for it. For now, we need to know that the x values are always on the left and the y values are always on the right. And if we have a table of values that is written horizontally, sometimes that happens, then what we're going to see is the x values will be on the top and the y values will be on the bottom. What we can do is we can check out the relationship. A table of values is just a way to show a relationship. We know there's a relationship between the computer sold and the games sold. We're not going to sell games if we don't sell computers according to this table of values. So we're always asking ourselves, well, how does y change based on what's happening to x? Well, we can see that we've noticed we have a +1 pattern for x, and we have a +4 pattern for y. What we can do is we can build an equation that can predict future numbers for a question like the one we saw with 2,512 computers. And we have a master equation that we use. And the equation is y is equal to mx plus b. And the book will show this as y is equal to mx plus or minus a number for the first part. We'll talk about now what these numbers mean because it's a lot of variables and a new formula is often confusing. What we have for our m in terms of how we're going to look at numbers is the m is going to be our pattern for y. And the number, the b or the n here, this one I call the bridge from the x value to y. So if we take a look at this example, we have a pattern of a +4 pattern all the way through on the y values. So I write my equation as y is equal to, the m becomes the pattern for y, that's a +4, sorry that's a 4 not a y there. It's a +4, so I write 4, then x, which means 4 multiplied to x. We learned this, right, in our polynomials and equations. 4x is 4 multiplied to x. So then that's exactly what we're going to do. We're going to go ahead over on the x side and we're going to multiply one of the values by 4. And it doesn't matter which one it is. We can do this down the line, choosing different values, whichever ones we want. And we can do 1, 2, 3, as many as we like. 1 times 4, the very first one, is equal to 4. But I need to get myself up to 6. If we go down to the next one that I have, 4 times 4 is 16, but I need to get to 18. And the next one I have, 7 times 4 is 28, but I need to get up to 30. Do you notice what you need to get from 4 to 6, from 16 to 18, from 28 to 30? You need to go up by 2. And so that is what I call the bridge. you need to bridge up by 2 to get back to your y value. And so here, this would be 4 times x plus 2 equals your y. In our first example, our y would be 6. 6 is equal to 4 times 1 plus 2. So you can create the equation from a table of values, and then we can use the equation to solve for x or for y every single time. And we're going to do some more practice of this before we solve this problem.